Okay, I wanted to show you putting this this receiver on the test bench for the first time. So my test bench is based on a piece of data acquisition equipment from a company called National Instruments called ELIVS, and this is a cool piece of kit that is primarily used in education. I just happen to have one on hand, and what this guy can do is a ton of analog input, a ton of analog output, digital input, and it has a prototyping stage, so you can do anything you want on it. I'm using it in its barest form with basically a function generator out and 2 channels in. And what's neat about this, because you'll notice there's no screen, is it connects to a computer, and it's all software instrumentation using cool software called LabVIEW. And if you're curious about that, that's where I started my career. But that's not really relevant to this conversation right now. So what I'm going to do is I'm going to generate a 1 kilohertz, 1 volt peak-to-peak sine wave, which is going to come out of that top jack. And you see it's going into this Y split of the right side of the aux input. And the other side of that is just coming out here, and it's got my probe leads for the red probe, which is, or sorry, the yellow probe, which is channel 0. And the red probe is connected to my speaker outputs on the right channel. You notice I only have 1 channel connected. I've got the balance all the way to the right. I'm going to test 1 channel at a time. And because in order to test this and to effectively measure power, you can't just do this into open air. This speaker cable is connected all the way over here to 8.1 ohms of 250 watt power resistors, which simulate a load of a speaker, a loudspeaker. And you notice there's a 4.1 ohm, 4.0 ohm. They're in series, so I get 8.1 ohm, and they'll get a little warm if I'm doing a lot of testing at high power, but they can absolutely take it. So I actually can see on my screen, my green trace is my measured signal from the function generator. And if I turn on my receiver, we should, there's the click. I'm reaching around for the volume control. Okay, all right, we're seeing some activity. The blue trace is that right channel output. So this is going to tell us if we have a nice sine wave output. It appears to be out of phase. That's interesting. I'm not going to think about that right now. So the idea here is you crank up the volume until you reach the point where you clearly see clipping or distortion. And because I've only got 1 volt peak to peak in, I may not hit it. I'm going to just give myself a lot more volts per division here. Let's go to 10 volts. And you'll probably see it distort eventually. There we go. So we're at clipping right there. And I don't want this to go on for too long, so I will actually click stop so that I can save that trace off, do some analysis on it, and then turn my volume down. And so I'll repeat that on the other channel. I might do it at a few other frequencies to generate a frequency response, and that's how I test this receiver. I will say this, that is a very pretty looking sine wave at 1 kilohertz.
So I wanted to just show you how I calculated the power output and linearity. So as I showed you, I repeated that measurement several times, and I use Gemini and ChatGPT, and really any tool can do this. And I said, hey AI, help me calculate the power output. I tell it the rating, the resistance of the power resistor, and I gave it the peak-to-peak readings in and out and the frequency. And this is good education, actually. You know, it then ensures that you convert the peak-to-peak voltage into an RMS. You calculate the power output according to the V squared over R law, and that just gives you power output in watts across that load. And of course, it is going to give you commentary, but it's really interesting that it read 33.5 watts peak output at 1 kilohertz sine wave into 1 channel when it's factory rated at 20, which is really good. And then I continued, and as I went, I just used this to data collect, and I typed in my my readings for each frequency, and then it generated this table, which I found really interesting. Maximum power output varied a bit between lower bass and 15 kilohertz. But what's really interesting, this voltage gain is incredibly linear. I actually did this twice. I did it once before I forgot to turn off the loudness and the bass and so on, and it wasn't consistent, which, of course, is what happens with loudness and bass and everything else. So once I had put it all to be totally flat, redid this reading on the right channel, I get a very flat output. So it's fantastic. And of course, Gemini continues to give these bits of feedback. So I thought you would find that interesting.